So we've already been talking about motion tracking in Blender for an hour and 15 minutes, and we've just started part 2. So there's probably going to be a part 3, 4, 5, since we need to go over camera tracking, object tracking, and probably deformable tracking. But we just want to springboard off of what we've been talking about so far. Um, we've been talking about the basics, the fundamentals of tracking, which motion model you should be using, like location, rotation, scale, perspective. We just want to build off of this theory. So on my sheet of things to go over, we are going to do join tracking, offset tracking. I hinted at this in the previous tutorial. And then we want to start talking about implementation applications like stabilization, corner pinning, which Blender calls plane tracking, and then also masking and compositing. So we're really taking the footage. We've already talked a bit about motion tracking, which is extracting data from the footage, and now we want to talk about the next step, which is the implementation, how you might use it creatively. So let's open up Blender and start part 2. So since this is a new project, we're going to need to fix some settings to begin with. So in the Output tab, remember, we want to change our frame rate since we're using image sequences, so I guess we can choose whatever frame rate we want, but all the footage was recorded at 30 frames per second, 29.95, 29.97. Generally 30 is the closest to all of these and is a nice number. So we're going to pick 30 frames per second, and then in the Render tab, before we import in our sequences, we want to make sure that we have the right view transform, which again is standard. It's going to give us the standard colors and not alter anything with Filmic. So we're going to go to the movie clip editor, which is where we live for motion tracking, and then open up the new sequence that I have for this, and we're going to be talking about obstructions. So A to select everything, open clip. We're going to be tracking Curious George, but there's going to be an issue with this one. So before we even talk about that, remember that right now by default we have our project settings. The endpoint is 1 frame, frame 1, and then the out point or the endpoint is frame 250, which doesn't necessarily match our footage. Set scene frames will fix this, so now we're going from 1 to 121, and then prefetch to load this into memory. This should all be stuff that you know since we talked about it in the first part of this tutorial. So let's see the footage. I'm filming this graffiti wall, and then we have, what is this? It's an obstruction. So for example, I want you to imagine that we're tracking Curious George's face right here. So we'd be tracking it. We have this obstruction, so we can't actually recover that data, and then he appears again. So there are 2 ways to handle situations, like 3 ways. The first way you can handle the situation is to not film this way. You do not want obstructions, especially if you know what it is you're going to track. That's the best way to do it. But let's say this is the footage you're given, or you're just trying to test out what you can do. So you have 2 other options. The first one is to track everything before the obstruction, then it gets obstructed, you can't see what's there, and then track everything after it. So we have the before, the after. The second approach is we can approximate what's happening behind the pole. We can't get it perfect because that data isn't there. We don't have any 3D data, just the footage. We don't know what's behind it, so we can approximate it and then get the whole thing in one track. The benefit to this is we get one full track, not a beginning and ending. Of course, the downside is we're approximating, so it's not going to be that good. So first of all, let's talk about the first approach. So we want to track this, and I've been vouching for affine motion model. Perspective is technically better. Affine's faster. I like using affine. We're going to turn on normalize, which again makes the tracking invariant to lighting changes. It's going to average out light intensities, so if a bit of shadow goes over or it gets brighter, it shouldn't be a big deal. Then in the tracking settings extra, we're going to bring up our correlation to 0.9, which again means every time it's tracking, every frame it's going down, it's going to have some confidence in how good the match is. We want it to be 90% confident, or else we want it to stop tracking. So that's why we did a correlation of 0.9. It should be very accurate, or otherwise it will stop. So let's add in a tracker. Control click. I'm going to do it on his nose. Control click, scale this up. Alt S is for the search box, and again we want this big enough so each frame it stays inside the search box. Of course, this footage isn't moving very wildly, so we can actually make this a bit smaller. Like that. Okay, so Control T to track forwards, it's going to make it exactly to where the obstruction goes into our pattern area, and that's expected because if it tried to match this, there's no way it will be 90% confident that this is a match, because something like a sixth of the pixels here would be drastically different. So it makes sense. If we had a correlation of 0, it probably would have just, I think it definitely would have kept going. So before we do any trickery, I think we can actually get 1 or 2 more frames. So we can scale this down. Again, this adds a new reference point. So from now on, it's going to be tracking relative to this frame. So Alt right arrow, scale it down just a little bit more. We can probably get this. Okay, it doesn't want to get it. That's fine. So this is the best we can do for this area. Control L to lock the tracker. Nothing we can do. So it's tracking on. Then we have our obstruction. But if we play this a bit further, Curious George comes back, so we can track him. So again, we did it right on the nose, so I'm going to add a new tracker. So again, this is not the same tracker. This is a second separate tracker with the same settings. So scale this up, and then we're going to track backwards a little, right until we get the obstruction again. Alt, left arrow. Again, we can probably get an extra frame. I guess not. Okay, so we have it up till here, and then we want to track forward so we get to the end of the shot, frame 121. Okay, perfect. Control L to lock that tracker. So what do we have so far? I'm going to lock to the active tracker so we can actually get it centered. So we play through this, we have 1 track, and then obstruction, which means everything starts to get shaky because there's nothing for Blender to lock onto anymore and to put into center. And then it appears again, but of course we need a lock to this tracker. And what we want to do is take data from the beginning and from the end and combine them into the same tracker with this gap in between where we couldn't do any tracking. That's the first approach. So how do we do this? You select all the trackers. You can either click one and then shift click, so you have all of them, or just click A to select all of them since we only have 2 trackers. And then in the track panel, you see this button, merge, join tracks. Of course you're going to hit this. And then one of the tracks disappears and is inherited into here. So now if we play this, everything's centered, some shake because there's nothing here, and then centered again. It's the same track. If we go to the graph information, you can see exactly what's happening here. We have data here, nothing here, and then data again. And again, this is representing X and Y translation data of the center point of our tracker. There's no, the police are outside. There's no information about skewing or anything like that. That's an affine, just location data for the center point. And something I didn't talk about last time, but should be very intuitive, we can clear stuff just like before. So if we don't want the data after the obstruction, we hit this button, it will clear it, or we can clear to the left like that. Of course, we want this whole thing though. That was weird. This whole thing though. So let's go back to clip. Okay, so that's the first approach. That is join tracks. It's 100% accurate. Everything we tracked is correct, but we're not getting at least an approximation of what happened behind the obstruction. So now I'm going to talk about how to do that. So I'm going to add in a new tracker on the nose. Again, we're going to use affine, same thing as before, and track forwards with Control T. So we make it up to here. And again, we can try to get 1 extra frame out of this. It's always good to have as many 100% accurate frames as you can get. Maybe if we make it a bit smaller. There we go. So that's probably the most we can get out of this. So how do we actually track this when the information isn't there? Again, this is just 2D. There's no way to get that information back. Well, what we can do is track a different area of the wall. So something like, you know, this tire, this shoe, we can track that and say, track this, but put the information on our original tracker. So we're not adding in a second tracker, we're just saying track something else, but keep the information on Curious George's nose. So how do we do that? This is called offset tracking. The way we can do this is hit G twice on the keyboard, G, G, good game. Put that wherever you want, so like the shoe. And you see we have this relationship line to our center point right here. So this is where we get the data stored. It's extracting X and Y data from this area, but it's tracking this area. So we can scale this up. And you can, again, as I was saying, you can see this in the relationship line that you see all over Blender. So it's saying these two are related in the way we've been talking about. So now when we track forwards with Alt-right arrow, you see it's actually tracking even though there's an obstruction. Now this isn't perfectly accurate because these things are actually pretty far apart. They're on the same wall, which is pretty good. It could be much worse than this, but if the camera rotates, which I'm looking for a phone I can use. Here we go. If the camera rotates, one area of the footage, for example this one, is going to be higher than the other. And since we're tracking this area, it's going to think that Curious George's nose is higher than it's supposed to be. So this isn't the perfect method. You want to offset track as close as possible. The more local you are to the desired point, the more accurate it's going to be, obviously. But this is the best we can do. So Alt-right arrow. See how far we can get. Aha, so now we run into an issue. Our offset tracker needs its own offset tracker. So how are we actually going to deal with this? So what we're going to do is we're not going to give this its own offset tracker. Instead, we can change where we're offset tracking. This is like pretty much the same idea as when we're tracking, we can change the scale and then keep tracking. Again, all that matters is the information right here. So click double G, and we can now change where this is so we can track the tire. Or another way you can do this that I hinted at in the first tutorial, go to the track panel, and under the marker settings, we have these offset parameters. So this is the X and the Y location of our offset tracking. When this is 0 and 0, we're not doing any offset tracking. So I'm just going to scale this up a little and then Alt-right arrow till we get out of here. And maybe one more frame. Let's do one more frame. Okay, so now our obstruction is no longer here. So you do not want to be offset tracking at this point. When you have what you're actually supposed to be tracking and it's visible, you want to use that. That's 100% accurate. But it seemed to actually do a pretty good job. So originally it was on the nose. Here it's only a couple pixels off. So this is actually surprisingly good. Usually offset tracking is a pretty loose approximation. But in some cases it can really work perfectly. So we should be done offset tracking. So we can either double G and center this, or of course 0 and 0. So now everything's centered and we're doing normal tracking. I'm just going to move our handles so our obstruction's not in here, and then we could correct this. I'm not gonna actually correct this. So now we're tracking the area next to the nose, even though we want the actual nose. Control T, and now it finishes the track because there's no reason for it to stop, right? It sees it the whole time. Control L. I'm sorry if you can hear the truck outside, by the way. I need to keep the fan on since it's so hot in here. Window needs to be open. But the microphone's right next to my mouth, so you can hear all those breathing and sipping sounds. Okay, so what was the point of it? The point of this is now we have a single tracker. Let's lock onto this and play. We have a single tracker that even exists when the thing's obstructed. So this is the power of offset tracking. What's the downfall? What's bad about it? We already talked about. It's an approximation. It's not that good. So generally, I would recommend always using join tracks. And if you're desperate, if you really need it, do offset tracking, even though it's not accurate, really. In some cases, it might not matter. One scenario where you're using join tracking all the time is not just obstructions, but let's say you're tracking this window over here, and then at some point I dip the camera down a little so it exits frame, so we can't track it anymore, and then eventually I tilt back up and it appears. That's when you're doing a lot of join tracking, when it's on the margins here, when it's on the margins. But this is pretty good, and now when we go to graph, we see one continuous graph without any discontinuities. Of course, this is because we did offset tracking, so there's not going to be the gap in between, and that's generally the idea of join tracking and offset tracking. So now you know pretty much all the fundamentals about tracking a point using which motion model, whichever motion model you want to use, which settings you should pick, pretty much. We didn't go over use mask, which pretty much says I'm going to define a mask area and only track within this area, or only add trackers within this area for using detect features. This isn't that important, so I'm not going to go over it in detail, at least yet. But with this and join tracking and offset tracking, you actually know pretty much everything you need to know about tracking points. So now we need to start talking about implementation, what you can use with this tracking data. So we've extracted information, what can we do with it? The first thing I want to go over, let me look at my list, is going to be stabilization. So how to stabilize footage. So let's actually change clips here. So I'm going to close this out and open up. I've dedicated footage just for stabilization. And I want to specify, we're going to be talking about 2D stabilization, which is kind of fixing when the camera moves and rotates and maybe even scales a tiny bit. But this isn't 3D stabilization, which is something that exists where you're moving the camera through space and you want to have that be a smoother path. This is very different. So let's actually talk about how to do this. So of course, set scene frames 1 to 180, prefetch to load that in. And let's just play through this footage and see what we're dealing with. Okay, so I made sure that when I filmed this, I would only have rotation, a bit of movement, and maybe a tiny bit of scale. So this camera isn't really moving through space. It's staying in the same general area. What we want to do is stabilize this so there's no motion, so that it doesn't rotate at all, and so that there's no zooming in and out, really. Okay, so how do we do this? Well, what we can do is track a couple points in this and then use that information to counterbalance the footage. So let's say we have a tracker and it's going up as we're tracking it. Well, what do? We do the inverse operation. We move the footage in the opposite direction. Wait, let's see. If you move up, you want to shove the footage in such a direction such that the tracker stays in the same area. So move it up. Footage goes down. If the tracker goes to the left, you want to move the footage right. I'm pretty sure this is exactly what you need to do, the inverse operation for stabilization. So enough theory, let's talk about how to actually do it. So let's say we want to stabilize our footage on this point right here near the center. So we're going to put that here. We're using location tracking. I'm also going to enable in here, since we've already put down our tracker, I'm going to enable in the tracking settings, normalize, and a correlation of 0.9 is what I usually do. And then let's track forwards, make that a bit bigger, track forwards with Control T, see if it makes it through. Okay, so it has some issue here with the motion blur, which means the pattern it's looking for is kind of no longer there because now all that exists is blurry footage. So there's nothing for it to match onto, so we can do this manually. Of course, we know where it is, so a lot of time you need to do manual supervision, G for grab, put that here. And generally, if you have a lot of motion blur, in this case there's only a little, so you have a long streak of motion blur, you want to put your tracker in the middle of the blur, always. In this case, it's not a big deal. So again, it's having an issue, so let's put that right there. Control T, see how far it makes it. Okay, so I made it to frame 180, Control L to lock. So let's just play through this, make sure it didn't hop anywhere. Okay, perfect. So we have one tracker, which again only has X and Y data stored in it. So with one tracker, we can do location stabilization. No rotation, because again, that requires multiple trackers. Let's do location stabilization. Where do you go for stabilization? The panel, the stabilization panel, tab, click it. You want to enable 2D stabilization. And this is just for visualizing what it looks like. We need to actually implement it in the compositor later. So let's actually talk about this visualization. So once we have this tracker selected, which is what we want to use for stabilization, we can just click this add, and it's going to add in our track. We can actually change the name of this to location stable, and it should change it back over here. Yeah, so we have location stable, and when we play through this, you're going to see nothing happens, nothing at all, not stabilized. And it does look a bit stabilized, but that's because we have lock mode in here, which centers it. So now, not stabilized at all. Well, what happened? We actually said use this for location stabilization. Well, again, this is just a visualizer, so which means we need to enable or disable the stabilization. So in clip display, you want to click show stable. And now when we play through this, you see it's stabilizing just the location. We still have the rotation, but if I hover my mouse, my cursor over this point, it's not going to leave it because it's locked onto that area. Okay, perfect. We can actually You might think that you can only stabilize to a certain location, you can only keep one place centered, and that's true. However, we can actually stabilize with location to multiple points, and it's going to average between them, I think is what it does, some kind of average. So let's say we want to track maybe this flower over here, which normally isn't a good idea because wind makes it move around, but I think in this case it's actually pretty stationary. So let's add a tracker, and then Control T. And that did it without any motion blur problems. So I'm going to name this, I'm going to name it Location Stable 2. And then in the Stabilization tab, we can take this one and add it in as well. Okay, so now it has two trackers for location stabilization. And when we play through this, you see it's kind of stabilizing both. It's kind of hard to tell because we have this rotation. But I believe if we put our cursor over one of them, this one for example, and play, you see it's not staying perfectly centered on the cursor because it's accounting for both of them, and in some cases it can't have them both be perfectly stable. So it has to kind of choose which one it's going to prefer. And we can actually control which one it's going to prefer. I think it does an average, but we can make it a weighted average. So back in the track, we see this weight and the stab weight. We're going to ignore weight for now and only look at stab weight, which it says influence of the tracking on 2D stabilization. Influence of this track on 2D stabilization. So 1 means it has 100% influence, and both of them have 100% influence, so it's going to equally choose between them for stabilization. If, for example, let's say we go to this frame, and we want this to not be accounted for, we can bring down the stab weight, and you see our footage is moving over a little. So now this has 0 influence, so it's pretty much as if we only had this one right here. So now if we play this and hover our cursor, it's going to stay perfectly stable. We can also do the opposite. So this has full weight, and we're going to lower the stab weight here. So now this one should be moving, as you can see, but if we hover our cursor over this one's going to be perfectly stable. You don't need to choose between 1 and 0. You can have, maybe we really want this to be 100% stabilization, so it's going to be really locked in on that, and then a tiny, tiny bit of influence right here. So let's say this one has 25% influence. So again, this one's not going to stay centered, but it's going to have a bit of influence over this. So that is stab weight. It's going to give us 2D control. Weight is for 3D control, but we're not doing anything 3D yet. So let's bring both of these back up to 1. Okay, so that's location stabilization. What about rotation? That's obviously the big issue here. So in stabilization, we want to enable rotation and scale. Scaling is not going to be a big issue. It's going to look at the distance between the trackers, which I think should be relatively the same. But rotation is definitely a big deal. So for this, we actually need multiple trackers. Again, we can't get rotation data from a single tracker. So with this selected and then this shift clicked, so now we have both selected, we're going to click add. And that's going to add both of these in here. And I guess at this point, it's not very accurate to call them location stable. So I'm just going to call this stable 2. And this one, stable 1. And something that you can do, again, this wouldn't be that important in this scenario since we only have 2 trackers, but you can color code them. And I've had some issues with this, but hopefully it works. Let's see. So with a tracker, we can enable custom color by checking this and then picking a color like, let's do red. And then for this one, we can pick a custom color. And again, I've had some issues with this. I know it generally works. Let's see. I've come from the future to explain why the color coding didn't work for me, or more specifically, why I couldn't see it. So when the trackers are in locked mode, which they are right now, you're not going to be able to see the color. So if we take a tracker, unlock it, take another one, unlock it, you can now see that they're color coded. And this might be a bit hard to see, so we can just disable the footage and then also remove the path temporarily. And now you can see we have a red tracker and a blue tracker. And if we, select the search box, you can see we have a blue one and then a red one. And again, you can just change these to whatever color you want. So now this one's a orange, which you can see like this. So back to your tracking tutorial. But generally, there is a way to color code them. We might go back to that. Don't worry about that for now. We're focused on stabilization. So here we have both of these for location, and then more importantly, both of these for rotation and scale. So now when we play through this, we don't have any of that rotation, right? It's the footage is now rotating to account for this. So if the shot is rotating this way, it's going to counteract this with the inverse operation of rotating this way, which is going to stabilize everything out. Now, something you might not like, in general, you probably want to have nothing out of frame. And what I mean by this is if you play, we have some negative space over here. If we play a bit more, we have some negative space over here. So we need to zoom in so that there's always something, or everything's always taken up. And you can either manually do this, or the best way to do it is enabling autoscale. So it's going to find the perfect zoom amount so that there's always full taking up of the frame. And you can see that this is actually very stable here. We do have a bit of distortion that can't be accounted for, but that's the motion blur and a bit of affine type deformation. Again, it's only accounting for location, rotation, and scale. But I'm going to disable autoscale. And I think to zoom this back out, we need to change this value to 1. Again, this is going to be how much you zoom in, and likewise, you can change the rotation. So what's actually happening here is we said it's stabilizing it, but notice that on the first frame, it seems that everything's perfect, and then it does its stabilization. Well, what if on this frame, we want this to be our reference point? So from this frame on, stabilize. So this is frame 49, and this is called an anchor frame. So if we do 49 here, everything's going to be perfectly centered, and then, stuff starts moving around. So we can just slide this around, and we'll get different results. But generally, you want to keep this on 1. So the first frame is going to be perfect, and then it starts deforming from there. So I think that's generally everything there is with stabilization. Of course, you can change the influence of how much location matters, how much it's correcting for rotation and scale. That's all pretty self-explanatory. So I said this is just a visualization. So if we go to the compositing, right, and I haven't talked about compositing yet, so we'll go in this in depth. So compositing is pretty much where we say what we want to render. So in general, what you're probably used to is you do something into 3D viewport, you model, you light, you put your camera somewhere, and then you hit render, and it's going to do it from this view. But really what it's doing is it's referencing the compositor and then rendering. So let's go back to the movie clip editor and then compositing. We want to enable use nodes so we see what we're dealing with. And by default, we have a render layers node and a composite node. What the render layers node does is it looks at our 3D viewport and then it sends that over to the composite, which is what gets rendered. So when you have something in the 3D viewport, this is what happens. It goes inside this node, it's stored in here, and then it feeds into what actually gets rendered. So we don't want any of that. So X to delete. We want to have our footage and then stabilized. So Shift A to add, just like in the viewport, and we're going to add in image, like that. If you don't want to do it this way, you can just go to input and then image. It's right here. Or in fact, I think we should probably just do image sequence, although both of them work. So we can just find where, I think it was stabilization, sequence, and then load in the sequence, just like that. Another way you can do this, oh, by the way, if you do it this way, you're going to have to mess around with these settings. So this one says how many frames long the thing is, so it should be 180. And then you probably need to do a bit of offsetting too to say where the first frame is. I wouldn't recommend using this way, which is why by default, by the way, if you want to view this, we need to add a viewer node. So we can actually view what's happening. You see it's actually moving. I don't prefer using this method. What I do instead, and we might actually end up getting the same kind of issue, I use the image node, and then it shouldn't be in here, or actually it is in here. We can load in our sequence. Yeah, we have the same issue. So we need to say this is 180 frames long. And then, by the way, if you don't have Node Wrangler enabled, which lets you do shortcuts like this one, that was one click, go to Edit, Preferences, then in Add-ons, look for Node Wrangler and enable that. So one shortcut this gives us is Control Shift and then click on a node, and that's automatically going to get connected to our viewer. If we duplicate this, we can Control Shift click to switch between these. But let's see, is this working how we expect? Yes. Okay, perfect. So you can see that when we play this, and you might need to go frame by frame since it doesn't load that fast. That's the biggest issue with Blender, really. The compositor is so slow, not as good as like Natron, After Effects, Nuke, whatever. But it's definitely a work in progress with this one. So the issue here is that it's not stabilized, even though here it's stabilized, so it's somehow not capturing this information. And to do this, we need to fix this, we need to add a node in between here and what we're viewing, which is here. So Shift-A, and then look up, I think it's called Stable. Yeah, Stabilize 2D, put that in between here. And you see everything goes away because it doesn't know where to pull the stabilization data from. So in here, we need to load in our not obstructed, that's what we were messing with before, but our stabilization. Okay, and you see it's doing exactly what we expect it to. So on the first frame, everything's going to be perfectly full frame. And then as we go, you see it's going to be moving around a little. And to really capture this, so we can actually see what's happening here, we're going to add in a background. So Shift-A, I'm going to use an alpha over, and we're going to be using this alpha over quite a bit. So this socket is the background, and this socket is the foreground. Pretty counterintuitive, but the lower down it is, the more in the foreground it is. So in this background, we have white. We can change this to red, and now we can see our stabilization. It's like moving and doing the inverse operation on our footage. Now another setting that's in this node that is actually more useful than you think is this inverse. So we have stabilization, which applies our stabilization data, or you can invert the operation. So if it's stabilizing by moving down, now it's going to do the opposite. Invert. Obviously not very useful for this, but if we stabilize, duplicate this with Shift-D, so that's Shift-D. Let's put this right here in our chain. So right now it's doing our stabilization operation twice, not what we want. So we want stabilization and then inversion, which obviously cancel each other out. These operations, so wait, let's go through this in order. Footage gets stabilized, then it gets inverse stabilized, so it undoes the work, and then it goes into this alpha over node, which is not going to matter because we're not going to see our background since we canceled out the stabilization. This gets fed into the viewer. We can get rid of this. Put this back here to get our stabilization. And again, even though we can see this, this is not what would be rendered out. So to do this, we need to have our composite node attached to this alpha over. So now when we render, it's going to be seeing what is feeding into the composite node, render that. So let's actually render out a stabilized version of this. Have I saved yet? I have not. That's a bit dangerous. I'll call this part 2 of the tutorial. So we want to render out this stabilized video. So in the output tab, we're going to set this to render as a video, not an image sequence, just for convenience of seeing the output. FFmpeg video is what you want to use for this, or AVI. Encoding, I'm going to change this to MP4, which is the standard for what you're usually dealing with. And then no need for messing with any of this, except for maybe output quality. We can make this high quality. In honor of this tutorial, and then output path, which is where we're going to save it to, I'm going to call this stable. And let's see, do we have everything? Yes, so our color is correct. We changed it back to standard. Our frame rate is 30 frames per second. We have all of this feeding into our composite. And by the way, if you guys got stuck on zooming in and out, V to zoom out, Alt V to zoom in, just a little something. So we have this feeding into our composite. And I think we are good to go. So now let's just save one more time, Control F12 to render animation. And we won't do all of this since, this is a live recording. We can do something like 30 frames. Once it gets to 30 frames, I'll stop it. Oh no, it's getting to frame 38, maybe even 39. That should have saved the video up until frame 38. So now if we play this, you see it's stabilized. Of course, generally you wouldn't actually do that background thing that I did with the red, but this is just to illustrate a point. So stabilization. What did we do? We took data with our tracking. We made sure that there are multiple trackers so we can get our rotation and scaling, because again, you can't get this with a single tracker. We're actually stabilizing for location on 2 different trackers. We can actually single this out by either removing one of them, or another way we can do this is with the stab weight. And again, this is just visualization. We can disable this actually. So now nothing's happening. However, if we go to our compositing, this is where it actually gets rendered out. So we have gone over stabilization. What is left in this part 2? Well, we need to go over masking, and I guess we need to go over plane tracking. So I'll pick one of those and then we'll go over it. So the next thing I want to talk about is adding a plane track, and this is basically the idea of taking 4 trackers, 1 for each corner, and combining this data together in such a way that we can track planar geometry. So in this case, we have footage from the first tutorial. This is when we did the perspective tracking. We have footage that has a planar surface, that's the floor, and 4 clearly defined corners. So we have this one, this one, this one, and this one, and they pretty much outline this panel that we want to have Blender recognize as a planar surface and manipulate. So for example, we could put something over this tile like a billboard type of scenario. So let's go to the first frame, shift left arrow, and like always, set scene frames. Now we're going from 1 to 200, so in point and out point are now matched. And then prefetch to load this into memory. This should be second nature, first nature. You need to know this immediately. So for tracking these 4 corners, I'm going to use affine. Ideally, you do perspective. I think that's probably the best thing for this, since this is a true perspective scenario. And I think last time we tracked it with perspective, but I really want to show the power of stretching and shearing, and that affine can handle this kind of scenario. So enable normalize so we don't have lighting change problems, and then correlation at 90%. Standard setup. Let's set up our 4 trackers. So I'm going to put one here, 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 and here. So on all 4 corners, A to select everything and then scale those up. And then let's see how well this does with the tracking. Control T. So it looks like only 2 of them made it. Not too bad. I'm sure we can just adjust these and it will correct pretty quickly. So let's go to the last active frame for this, which is around here. L to center this. We want to add another keyframe, and we can center this a little, just like that. And again, it's going to be referencing this from now on, since we made this with a keyframe mode. So it's going to reference this to try to match the pattern. Control T to keep going. Okay, this one made it to the end, and then finally, the car's outside. You wouldn't believe. So now, final tracker. Let's find the last active frame, which is this one, or it's around this one. Doesn't really matter. And it's very close to the border. So I'm going to increase the search area, but also decrease the patterns, because we do not want the pattern area to be hitting the edge of the frame. That will make it stop. So Control T, and we've done it. We have 4 trackers that have made it to the end. So select everything, Control L to lock, and let's just review that everything looks good. Okay, so we're really defining this tile. Yes? Okay, I think that's going to be good. So how do we actually add a plane track? So obviously, if we took a square and pinned each corner, this is pretty much corner pinning, pinned each corner of that square or rectangle to a tracker, we get exactly what we want. Well, there are 2 ways to do this. One is the manual approach, which we'll go over. But first of all, I want to talk about the built-in automatic approach. And that is in the solve panel, we have something called plane track. If we hit this right now, nothing's going to happen because we need 4 trackers. Even if we select 2 of them, not going to work. So we're going to select all our trackers with A, and then create plane track. And you see it defined this rectangle, and if we play it, it seems to be tracked on pretty accurately, almost as if it's on the floor, projected on the floor. But of course, it's not outlining our tile. So it has the right kind of perspective and motion, but not the right location and space. So your first instinct is probably going to be to select a corner, left click and move, which moves the whole thing, which might be what you're going for, but you really want to move each corner individually. And there's this well-hidden tip on the bottom here. says on the bottom, I can't move my cursor else it changes. It says slide plane marker, which is right click. So if we right click a corner, we can now adjust this. I believe we can hold down shift to slow everything down. And we want to do this with each of these. So right click, hold down shift for fine control. And right now if we play it, you see it's still tracked on and pinning those two corners. So we just want to finish this process to define not only the motion, but the form or the shape of our plane. Okay, so let's see how this is. And I believe we can just hide the footage, see what this is looking like. So you can really see this tile, how it's supposed to be. So let's just make sure. I think we can do a bit more adjusting. I want to get some of the cracks inside this plane. And the thing is, we only need to adjust this once. There's no need to do any keyframing because all our information is stored in the trackers, all the keyframe information. You can think of it that way. Okay, so that is looking pretty good. So now let's say that we want to take this and put an overlay. So an image that looks like it's projected onto the tile with the right perspective. There are two ways to do this. One way is the visualization way. Same thing that we did with the stabilization. It's just visualizing this inside the movie clip editor. It's not that good, but we'll go over it. And then the other way is in compositing. So inside our track panel, we go inside plane track, and you see we have our plane track, which is this one. We can name it to something like tile, and we can add in an image. Of course, we don't really have any images in here, so we need to import an image. Sadly, there's no way to import one from here, I don't think. I wish there was. That's something that should be fixed, but either way, we can open up a new window for the image editor is one place we can do this. I think UV editor is another. Open, and we can do that voting picture I showed in the first one. That says 68% of people wanted this, along with individual tutorials on this, and also 7% really wanted this. And for the 25% of you, you're probably not watching this video since you didn't want it. But either way, so we have this photo in here. Let's bring this back to properties, if I can find properties. It's not properties, there we go. Okay, so what we want to do is bring that over. So what we want to do is with image, we want to click voting, and you see it kind of works. If we play through this, it's tracking on, but you're only seeing half of it, and the half you're seeing is kind of shifting. It's not a very good way to visualize this. It kind of looks like view distance. So anything that's very close to you is going to get cut off, and as you go further away, you're actually going to see the image. And you can see how that kind of works here. Okay, so clearly this is just a way to visualize it. We can also play with opacity to see through it, so that's transparency. I do not recommend using this way. So once we have this, we want to talk about the compositing method, which is much better, much better. So in compositing, we have the node setup from before. We don't need any of this, I don't think. So if we Control-Shift click this, we now have the wrong footage, because again, this was our stabilized. So we can open up our perspective and then sequence, load that in. Okay, so now we have the right image sequence in here. And if we play through this, you see it's updating, but we want to integrate our planar tracking information. So I'm going to talk about the node that does this and pretty much how it works. So Shift-A to add a plane track deform. So first of all, what happens if we put this in between our graph right here? Well, first of all, everything disappears, and that's because you're trying to have it do a plane track deform, but you're not referencing which plane track that is. You could have multiple plane tracks. So we need to define which one that is. So we need to select what footage we did it on, that's perspective. And then it was inside our camera object. Don't worry about this part yet. It will become more obvious what this means when we do camera tracking and all this. But basically our plane track was stored inside the camera. You can think of it that way. And then we want to select the tile, which is what we called it. Okay, so what happened here? Well, what it did is it took our footage, it was just this rectangle, and it corner pinned it to this pretty much our tile. And you can see it's playing as if the video is playing normally, but it's kind of squished into this weird perspective situation. And we can even enable, you're probably not going to see much difference, but we can enable motion blur. This is calculated for when we have our plane track already, and we can control it. But the point is, this is not really what we wanted, right? We want to put something over it, not actually squish the thing itself. So what are we going to do? First of all, let's detach this. And we want to, let's say we want to overlay the same image as before. So what we're going to do is we're going to add in a alpha overnode. Pretty much the same thing we did with the stabilization when we wanted to layer things. Alpha over. In our background, we want the footage. That's what's going to be in the background. And then in the foreground, we want the image. That's what's going to be overlaid on top. So let's add in a image. And we can already select this, I'm pretty sure. Yes, voting, because it was already imported inside. So we can make this the foreground, and now when we see this in our viewer, Control-Shift-Click, if you have Node Wrangler, you see it's pretty much just overlaid a still image over our video. Not that impressive. So how do we actually constrain this and squish it using corner pinning? Well, what we can do is process this image, the voting image, through the plane track deform. So we can just put that in here. And you can see it's pretty much put it inside the tile with a bit of motion blur. So we can disable that and enable that. Let me zoom in with Alt-V so you can see the difference. And basically the way you want to think about this is samples is how much processing power Blender's putting into this calculation. How good is the motion blur going to look? So here's one sample, doesn't do anything. Two samples, a bit better. You can see it's pretty much one image shifted over another. 16 is very good. And then with shutter, it's very similar to how a camera works, shutter speed. So something very big, like 10, lots of motion blur, something like 0, no motion blur. So we're going to keep this at 0.1, let's say. So a tiny bit of motion blur is going to be fine for this. And you can see pretty much what it did is it just squished this into the tile, and it's tracking on properly. So that's one method, or one way we can use this inside the compositor. Oh, and by the way, if you want to get a bit trippy, we can also feed this into the tile. So now we have the footage inside the footage, and you bet that we can probably repeat this process ad infinitum. And you never get to say that word, and you just keep layering this inside each other. I think that's the correct way to say that. So that's one thing you can do with this plane track deform. Another thing is you see this has two outputs. It has this image output, which is just going to take whatever the input is, squish it, and then output it. And then the other thing is this plane, which you can think of as basically a black and white masking type image. So basically wherever it's white, the footage will appear, and black, it won't. So let me show you what I mean. So let's add in, you know what, we can just change the color of this to something like blue. So in the foreground, we're going to have blue, and of course it's overtaking all of the footage because it's just one over another without any masks. These trucks. Okay, we can add in a mask. So with this plane, we can put this into our factor, and now you can think of the foreground only being applied where the mask is 100% white. So again, let me show you. This is where the mask is white, and I'm pretty sure this is also affected by motion blur. We're probably not going to see it because it's very subtle. I think you could kind of see that. Let's zoom in. So focus on this perimeter here. So here's a shutter of 0, no motion blur, and then motion blur. So it also affects the mask itself, which makes sense. And it's going to be a bit more transparent on the edges, which is pretty much what you want. So let's view this. And this is without motion blur, so it's going to be very crisp. So what we see here is a blue tile. And we could do this with each of the tiles, assuming that we can put 4 trackers without them leaving frame. And if they do, we can use offset tracking, which is what we talked about before. So you can basically see what's happening here. Another cool thing you can do, I don't want to talk about compositing too much, but I do think it's part of the motion tracking process, what you can do with it. Another thing we can do is affect this mask. So something you might want to do is a dilate / erode. So let me show you what this does. So basically, we are taking our mask, we're using the mask output and feeding it into this dilate / erode. If we put in a big value, it's going to expand the mask. Let me pick something very big. It's going to expand it. Negative number, it's going to eat into it. And since this is what's being plugged in as our mask, right, what we're going to see is that this is now smaller inside the tile. So -40, shrinking. And if, again, since this is all one planar surface, it will all track on correctly. So even if we shrink it, it really looks like it's tracking correctly. Same for the opposite. If we make it, I don't know, 50, it's overextending. Of course, it's going to get chopped off, but that's not a big deal. Imagine that isn't happening. It is tracking on properly. So that's just a little something. So that is the compositing side of plane tracking, but there's actually a way to do it manually. And you might think, why would you want to do it manually? It gives you a bit more control, but it takes some time to set up. So first of all, let's just clear our graph over here. So when we come back to it with masking, it's going to be fine. So what we're going to do is in the layout, we're going to do this manually. So let's take our bottom window here and convert it to a 3D viewport so we can see what we're doing. And the same way that when we talked about, the tracking fundamentals before, we pretty much track something and then put that tracker in our scene as an empty, the empty stored the data, we're going to do a similar type of thing here. Okay, so how do we do this? So first of all, delete everything that isn't the camera, and then in the properties, that's N for properties, we are going to zero this out, and then bring this up so it's facing directly down from the camera view. And then the way we bring in these trackers, I'm going to get some water. Do not want a scratchy voice so I can keep going making a part 3 and all that. But the way we import this is we select everything we want to import. Reconstruction, and then link empty to track. We've already done this before, it shouldn't be that new. So if we go to the camera view, we see we have 4 empties that are defining our tile. To make this a bit more obvious, we can scale these down. And then even in our camera, as we've been doing, we can enable background images. And then inside movie clip, we should have perspective. So let's play through this. You can see our trackers are attached to it. Make those even a bit smaller. Whoops. I'm also scaling the camera. Be careful not to do that. So just select these. That is selecting the camera. Okay, so now we've just have the empty selected, scale those down, and now we are tracked. So how do we do the equivalent of what we did in the compositor manually, which gives us more control? Well, we have 4 trackers. So we need something with 4 corners. That's going to be a plane. So Shift A, mesh, and then plane. And we can kind of match this up initially. It doesn't have to be perfect. Rotate it with R. Scale it down a little. Again, this isn't the most important part. So now what we need to do is first of all align it on the first frame. We are on the first frame, you can tell because there's a 1 over here. You see this changes. What we want to do is align our vertices and then parent it to these empties. So with 1 empty selected, we want to move the 3D cursor there. So that's Shift S. So Shift S for this pie menu, and then cursor to selected. It's going to move our 3D cursor. And then with this, we're going to go into edit mode, that's tab, and then with the vertex, Shift S, and then selection to cursor. So cursor to selected, then selected to cursor. And we can repeat this process, although I was given a tip on how to do this faster. If it doesn't work, it doesn't work, but let me try it. You want to enable snapping, and then pick vertex snapping. So let's try that. So if we select a vertex and then move it, aha, it snaps. So that is the fast way to do it. And that's going to be very important in deformable tracking. So just snap those in. Okay, so now we have this initially set. Of course, if we play this, there's no attaching or parenting or relationship lines going on here. So how do we actually get the vertices to each follow their respective empty? So the way we can do this, again, this looks very weird from a 3D perspective. It's something that it's kind of like an optical illusion. We're looking at it from the camera view. And this is really what's happening in the compositor, by the way. It's just corner pinning. It's not true 3D perspective, which is why I don't like what the plane track is called. It's not really a plane track. It's just corner pinning. Just a gripe. What we can do is edit mode, select a vertex, and then once we have this vertex selected, we obviously want to use this empty. Hold Control, click it. Whoops, I missed. Hold Control. Okay, so I figured out how to select this thing. There was nothing wrong with what we were doing. We just needed to be super, super precise. So again, what we need to do is select the relevant vertex. So with the plane selected, go into edit mode, select the vertex, and hopefully this time I can get it. You want to control click very carefully. We did it. Okay, so vertex and then relevant empty, make sure nothing else is selected. And then what we do is Control H, and this is going to open up the hook menu. And then we want to hook to selected object. Okay, what's this going to do? When we go into object mode, you're going to see now that only this vertex is hooked onto this empty. And I'm pretty sure that the follow or constraint to F curve isn't necessary for doing this. Actually, let's prove that it's not necessary. So again, pick the next vertex and then very carefully control click. I feel like Blender's selecting needs a bit of work, especially with the going in between windows is kind of difficult, but you can do it without constraining to F curve, although I would recommend it. Control H and then hook to selected. And then when we play through this, it's hooked, but we can also take this empty and constrain it. And I would recommend doing this because we do not want to be dependent on the camera. So right now, if we move this, these two empties are still attached. And if we do the rest of our hooking, it's going to move that part of the plane. So unless you want to be able to move the camera and have the plane stay with it, you don't want this. I just want this to be settled on the floor regardless of where the camera is. So let's just do the moving with the camera example. So vertex, control click, control H, hook to selected. Okay, let's make sure that's working. Okay, perfect. Go back to the first frame. Vertex, control. This control clicking, it's got me hot and bothered. Control click, control H, hook to selected object. Okay, so now if we move this camera, yes, it is moving, those vertices that are still pinned, which is not what we want necessarily. So we are just gonna constrain those. I think we have to do them one at a time. No, should have done all of them. So now it's independent of the camera. And now if we view this, you see we have manually kind of, manual corner pinning in some sense is what we just did. But now we can play around with texture coordinates and all that. So for example, if we wanted to add the image, shading, some material, and then load in the image. Where is it? There it is. Okay, perfect. And this automatically does the corner pinning for us. And we can see that this is what's actually happening under the hood here. So if we go to the 3D view, we're getting this weird corner pinning that has a bit of warping, but it really isn't too bad. Yeah, look at that. Okay, so that is everything you need to know about the plane track. And then finally, we need to talk about masking. So we can actually just delete this setup over here. And then back inside the movie clip editor, we can open up our perspective. And I don't want to get too deep into the theory of masking, how to mask a complex object like your hand, but I just want to talk about how you can use trackers to make your masking process faster. So with all of these tracks as before, maybe we can name one of them, the one we're going to use. We can call this mask track. So what we want to do is go to the masking space and add in a new mask. And we can just draw in a mask by control clicking. Yes. So control click for this linear interpolation, or control click and then hold and drag this to get this Bezier curve. Look at that. And we can also seal this up by enabling cyclic. So right now we have this mask, and if we play through this, it's just kind of overlaid on top without any attachment to the floor. It's not really attached at all. So the way we can use trackers to speed up our masking workflow, imagine we had a tracker on each of our fingers. What we can do is we can do this one at a time. So for example, we can have only this part of the mask selected, that part of the mask selected, and then for the active point, which is what it's going to be parented to, we can just pick this. So inside our perspective footage, inside our camera, again, we're going to explain what this camera means once we get deeper into the 3D stuff, like camera tracking. We are going to select the mask track. And now this point only is going to be parented, as you can see. Of course, that's not really what we want. We want all of them. So back on the same frame, select all of them with A, shift click the tracker, whoops, control A, whoops, A to select everything, shift click the tracker, and then control P is going to parent it. So now our whole mask is angry drivers outside. So now our whole mask is parented. And I believe we can also use the plane track. So Let's actually just delete these. Does that delete it for each one of these? No. So let's actually just delete this mask and add in something like a square. Put this over here. Okay, so now we have the square mask. Okay, and what we can do is for each of these, we can parent it to the footage and then to the plane track, which is just called tile. And you can see this is now using planar information. So when we do all of these, I believe we can't do them all at once unless we hit, let's try it. We hit A, shift click the plane track, control P. Is that, yeah, that works. So now we have a mask projected in some sense onto our plane. Well, why is this useful? Well, because in the compositor, we can use this mask. So if we just do something like an alpha over, put this in here, and then in the foreground, we want some kind of color like, let's do green. We haven't done green. And for our factor, just like we used the plane track before, this time we can use our mask to, use as the factor. So Shift A, add in a mask, hook this up to our factor. So again, this is what's going to decide what's in the foreground. And we can choose our mask that we created. Okay. And you're noticing that this is kind of loading in, but it doesn't have any of the animation to it. It's kind of like we did a mask on frame 1 and that's it. The reason that is we need to actually enable motion blur for some reason. Enable motion blur, and then you can see that this is actually tracked on properly. And of course, this motion blur works just like the other one. Zoom in with Alt-V, where the shutter is the strength, so something like 100. There's a lot of motion blur you can see on the perimeter of this. Samples is how much, pretty much the quality of this. So if we have 2, very low quality, 16, whoops, 16. So that is the idea of using trackers for masks. So that is, I guess that's everything I wanted to, is that everything? We talked about everything we wanted to talk about. So we developed the theory of trackers. So join tracks, offset tracks, this is what to do with obstructions, how to handle these kinds of situations. And then we started talking about, applications, how to stabilize footage, how to use the plane track to combine different trackers or multiple trackers to, get planar information in some sense, which is really just a cheat of corner pinning. And then we also talked about masks and the compositor in general. I feel like you learned a bit about the compositor in this video. So that is all I wanted to talk about for this one. Again, if you enjoy these tutorials and want to fund these tutorials, you can fund me directly via my Patreon. So I have a Patreon. There's 26 of you, 25, 26. I really appreciate all of your donations. You don't need to do it. It's just free content on YouTube, but I appreciate you guys funding exactly this. So in part 3, we're going to start talking about camera tracking and maybe object tracking. We'll see if we get into it. And then we still have deformation tracking is what I'm going to call it. So we still have a lot to go through, but I feel like we're starting to get a grasp of everything the motion tracker has to offer. Pretty much the only thing left in tracking is I feel like we know most of what this track does, but not much of the solve, which also, once we know the solve, we know about the camera, the lens, and also the objects. We're going to know what that means. So a bit more to go through, but thank you guys for watching. I'll see you in the next one.